Okay, here we are on our unit on energy, force, work, and power. Now, these are going to all be related into one another. One is going to dovetail into the next. And of course, power is going to also help us understand power in the electrical field. So let's get started. We have some objectives. First, we need to be able to define energy. We need to understand force and its measurement units. We need to understand work and the units with which it is measured. And we also need to understand power and its units of measure. So let's look at energy. And energy is fairly simple to define. It is the ability to do work. Now we're going to have to further define what we mean by work, but the ability to do work is what energy provides. Energy can be found in things such as light, sound, and in our case, most importantly, electricity. So, before we can define work, because remember energy is the ability to do work, we need to define force, because force is going to be a component of work. Force is any interaction when unopposed that will change the motion of an object. Okay? Force is measured in newtons, and we abbreviate newtons with the letter N. And here's the definition or the formula for a newton. 1 newton equals 1 kilogram times 1 meter per second squared. Now that may seem a little odd, the meter per second squared, but that's actually a component of acceleration. Okay? So if you think of a scalar for speed, you would measure the speed of a bike in 1 meter per second, and you could say how fast he is going. But that would be either his average speed or a constant speed. But if that bicycle is continuing to accelerate at 1 meter per second, you would say it is accelerating at 1 meter per second squared. Okay, so that means that every meter he travels, he's going another meter per second faster. So that would be a acceleration unit of 1 meter per second squared. The pull of gravity is actually an accelerating pull. So if you would drop a ball from the top of a tall building, the ball is not going to fall at a constant rate. It's going to start to fall at a specific velocity, but then it is going to increase in velocity as it gets closer and closer to the ground, and that is going to be acceleration, and that would be some component of distance divided by time squared. And in our case, because this is a metric system, we are using meters and seconds for our acceleration component. So hopefully this will be cleared up with a little example here. If I have a box that weighs 1 kilogram and it is off the ground at 1 meter, and we push it off that ledge to where it falls, and as it's falling it is accelerating as it gets closer to the ground. When it falls at 1 meter and it accelerates at a rate of 1 second squared, it is going to equal 1 newton. Okay, let's look at work. Work is simply the force times distance. Okay, we had to understand force. Force is measured in newtons. And distance, this is going to be another metric term. So distance, we're going to actually use meters. Work is measured in joules. That is a system international unit, or we could just call that a metric unit. Joules is an SI unit, metric unit. And 1 joule equals 1 newton times 1 meter. So the units for joules are actually newton meters. And well, one way to express them would be in newton meters. Let's look at an example here and look at how much work is going to happen if we have a box that has a force of 6 meters pulling on it. 6 newtons pulling on it, and we are going to travel up a flight of stairs that is 3 meters high. Well, if we use our formula right here, we know that to get a joule, we're going to take whatever newtons we have, and we're going to multiply it times the distance in meters that we are traveling in a linear fashion. So even though these stairs were traveling angularly up, the box itself is traveling from this distance up to 3 meters in height. So 6 newtons times my 3 meters is going to equal 18 joules. Okay, you could say 18 newton meters, but 18 joules is probably a more appropriate way to denote that. Okay. So now, how is this going to relate to power? Okay, so back here we had our definition for work. Well, let's look at power and its definition. Power is the amount of work. So we had to understand work before we could understand power over a given amount of time. See, this in work, we didn't have a time component. So if we traveled up the stairs here and it took us an hour to get up the stairs, or it took us 10 seconds to get up the stairs, it didn't make a difference as far as the amount of work that is being done. All we're doing is taking that 6 newtons and we're moving it to up 3 meters, and that is the work that is being done. Now the power that is being displayed in that act has a time component to it. So power is the amount of work over a given amount of time. So power, again, is a SI System International unit and is expressed in watts. And 1 watt equals 1 joule. Remember, a joule is our unit for our work, divided by 1 second. Okay, so let's apply this same example to this this new definition that we have for power. So we know with 6 newtons and 3 meters, we're going to have 18 joules of work to move that box up to the top of the stairs. But let's say that we do it in 2 seconds. Okay, that's the time that it takes us to get up to the top, and so we divide our 18 joules by our 2 seconds, and we're using 9 watts of power to actually get that box up to the top of the stairs. Now, if we move up the stairs slower, we're going to take 3 seconds in this case. We're going to take our 18 joules divided by our 3 seconds, and we only have used 6 watts of power. So if you think about this, if I am very tired and I need to move this box up, it's going to take less energy, less power for me to move this box if I do it very slowly. So let's say it takes me 5 minutes to move this up, where I do 1 step and then I rest. And I take another step and I rest. And I take another step and I rest, until it takes a considerable amount of time. The longer it takes for me to move this box up the stairs, the larger my denominator is going to get. And the larger my denominator is going to get, the less power it is going to take for me to get that up the stairs. Another way to think about it is this is a System International unit, watts, for power. But in America, when we use the imperial system, the unit that we use is horsepower. And horsepower, if you have a car that has a big, powerful engine in it and you put it on a drag strip, it has, because it has high power, it can travel that quarter-mile distance on the drag strip in a very short period of time. If you put a car that has not a very powerful motor at all, a much smaller motor, and it travels over that same distance of time, the time will be much longer because it is not as powerful. So as far as power goes, time is definitely a component. Let's do a review here. Define energy. I want you to think about that for a minute, maybe pause the video, and we can come back and review the answer. Okay, energy is the ability to do work. Okay, now it's going to be important for us to define work, but energy is the ability for us to do some sort of work. What is force and what are the units of its measure? A force is any interaction when unopposed that will change the motion of an object. Okay, so think of gravity. If I'm holding a ball in my hand, I'm using as much force pushing it up as gravity is pulling it down, and that's why it's not moving. As soon as I let go of the ball, I no longer am pushing up on that ball. I'm not pushing against the force of gravity. So that would be that unopposed. When the force is unopposed, gravity is no longer opposed when I let go of it. It will change the motion of that object. So gravity is a force, and that force can be measured in newtons, which is a SI unit, and is abbreviated with the letter N. Define work and the units with which it is measured. Okay, pause the video, and we'll come back in just a minute. Okay, work is simply the force times distance. Okay, so we have a certain force that is pulling on us at all times, gravity, and we have to, let's say, lift a box up on a shelf, and there's going to be a certain amount of work that we're going to have to do to lift that box to overcome gravity and put it up on the shelf. That force, the gravity, and the distance, the shelf, multiplied together will give us our work component, which is joules. And so because it's an SI unit, the force would be measured in newtons, and the distance would be measured in meters, and you multiply those together, you get Newton meters, which joules are measured in Newton meters. What is power, and how are its units measured? Okay, pause the video and think about that, and then we'll come back in just a minute. Okay, power is the amount of work over a given amount of time. Okay, so work was measured in joules, and it was just force times distance, but we never really took into consideration how long it took us to lift that box off of the floor and put it up on the shelf. Power is the amount of work over a given amount of time. Okay, so now we're putting that time component in that, and power is measured in watts, and we use the letter W to abbreviate watts. That is a quick lesson on energy, force, work, and power, and I hope this helps you in your study of electricity. We'll see you in the next lesson.